Now, what we have here, guys, question 17. The diagram shows the curve y equals x squared plus 2 in the domain 0 less than x less than 5. Saviour of us is going to be the old calculator table function. Worth a lot of marks, just being able to press a couple of buttons. X squared plus 2. Start at 0. End at what? 5. And then step of 1. Now, it gives you the points. You could actually read them off the graph pretty easily as well, couldn't you? Like the point 1, 3, 2, 6, 3, 11, 4, 18, 5, 27. In the leaving cert, they won't draw that for you. You'll be drawing that yourself. So it's good to know that you're going to be forced to draw it yourself anyway. So what are the numbers we're going to put down here then? 0, 2, 1, 3, 2, 6, 3, 11, 4, 18, and 5, 27. Okay, nothing too stressful there. Hence, use the trapezoidal rule to estimate the area between the curve. Okay, we're going to do some heights here. And you can just, what's the h value? Sorry? The h value, guys? 1. Okay, you write down each value. This one's 2, 3, 6, 11. Wait, I'm missing one, am I? Oh, sorry, 0, 2. Yeah, I have to shift all these over one. Oh, that's pretty awesome there. Now, 18 and 27. Okay, so shifted one over there. Okay, so what's the very, we're going to do trapezoidal rule, roughly equal. It's the old squiggly equal sign. It's not made up, I swear. And what we get is h over 2, first plus last, 2 times the remaining. Best just to learn that off, or at least know how to modify the formula that's in the notes on page, I think it's 11. So what's the h value? H value? 1 over 2. First value? Last value? 2 times the remaining? Plus 6, plus 11, plus 18, plus, that's it. What is that answer when you put it all in the calculator? Huh? 52.5? Okay. What? Oh yeah, no, there's nothing wrong with the calculator. If you're wondering what this is based off, the trapezoidal rule, it's based off the area of a what's called a trapezoid or trapezium. So remember when I said trapeziums are like trapezium? That's an example of a trapezium. It's like a rectangle with a slanted side. So if anybody look up for a second, might be asked something like this soon. Is that when you're talking about the trapezium, see the way I'm joining them all into trapeziums? We're really getting the area of the trapeziums I drew. So it's not 100% accurate. So you're actually getting the area of what I drew as opposed to the smooth curve. So it can be overestimated or underestimated. So the accuracy doesn't depend on the calculator. It depends on the formula we used. The narrower you make the channel, the more accurate it gets. So what I mean by narrower you make the channel, see the way h equals 1 at the moment? If I turn that into h equals 0.1, where we make it really, really narrow, the answer gets much more accurate. Okay? Huh? Oh no, yeah, it's just basically find the heights, use the trapezoidal rule, and they're asking you to do an estimate anyway, so it's no big deal. Now, what they then ask is this: they go, we got an answer of 52.5. Okay, and it says the actual area computed by integration is 51 and 2/3. Find the percentage error. Percentage error is a formula that's not in your notes, and you got to know. Percentage error equals your error divided by the real value, the actual value. We would have done this in the arithmetic section. Multiply by 100 over 1. What is the error? You enter 52.5 in the calculator, and see this button here, above the fraction sign. It's a very useful, button. You can do mixed fractions this way. Shift, press the button. It wants me to take away 51 and 2/3. And what we can get here is that the error is 0.833, otherwise known as 5/6. I have no idea why it's not converting it into that. Let's just go with 0.833. Okay, so this 0.833 is the error. What's the real value? Yeah, R1 was an estimate. The real value, however, is the red circle, the one we're given. It says it in the language of the question. So divide 0.8333 over 51.23, multiply by 100. What you get, Sam? 1.6%, or 1.6. Finally, comment on the effectiveness you think, how effective the trapezoidal rule was in this case. Well, my answer is 1.6% off. It's okay. It's a reasonably small error. Could you suggest a way to improve it? Remember I mentioned it earlier. You could do smaller intervals. So you could say you could suggest another question might be, what could you do to improve this? You could say change h equals 1 to h equals 0.5. Make the interval smaller to improve your results. Who else? We had their hands up? No? Okay, we're good. Okay, guys.